So no, you're fine. So being in this class means that you are in accelerated 7. By the time you leave middle school and you go to high school, you will enter high school instead of going to high school math 1, you'll go to high school math 2. So you'll be a year ahead, which makes more flexibility in your schedule. It's really nice. Fun. Maybe I would have to make it live. Right now you guys can't see it. I just made 4.3 live this morning so you guys can see it. So yeah, I would just have to go in and make it live. So it probably wouldn't be available till like I need time to do that, so it just wouldn't be available till at least second block. But you have class until then, so that'd be fine.
Okay, so but if you do that,
yeah, I'll let you guys know. It wouldn't be like required homework. I would just open it up so you guys can get through it. Okay. Name tense, guys. If you have your name tense, please put them up. Yeah. That's high school math 2. So like kids that had already taken math 7 in the 6th grade, then can take math 8 as a 7th grader. Over the summer, you're able to take math 1. There's a summer school class. They did that, and then now they're in math 2. So I teach a high school math 2 class. That's why I have to leave lunch early and come back here and I have 8th graders. That's that class. No, they can't be. Like that would be a way accelerated track that most kids would have no reason to end up on. And if a 7th grader took math 2, they'd have to go to the high school the next year for math 3. Like they wouldn't go to the high school; they would just go there for that single class. So that's kind of annoying.
we had a 6th grade doing my friend.
Yeah, but they were probably just going there for math 1 or something like that.
Alright, what about senior year? Do you think it's low classes?
Then it becomes electives. Then you choose what you take. So there's like financial algebra is a math elective. I would suggest everybody take. Financial algebra is a really important course. So, any big questions from the 4.2 homework here? Any big questions from last night's homework? Some of you have yet to submit it. That's fine. It's not due till midnight tonight. But please try to make sure you do get it submitted by midnight tonight so I can check out your submissions. You have 3 chances at it. You need to get above an 80%. So if you goof up on one and you need help or whatever, come meet with me, come work with me. Work with your peers, check Khan Academy, check any of those other math websites. Any big questions? What, any questions?
Can you get that on Amazon, that mic?
This, I have no idea. Mr. Estes just handed this to me this morning and said, here, try this. Because if you watch the video from yesterday, this right here is our class video from yesterday. The audio is kind of goofy, so I'm trying this mic today, and we'll see what happens.
I subscribed to you. So did I.
Thanks. You guys will help me become more popular. I used to be able to say the joke that you can search Micah Hudson, and I am not the black hip-hop dancer, because that used to be the most popular Micah Hudson on YouTube. But now I think I've surpassed him, so now that joke's not as funny.
If you ever get like a golden play button, you should put it in your classroom.
Golden play.
Yes,
I don't think that's going to happen anytime soon. Your homework for tonight is right here in the 4-3 folder. It's exactly like last night. But tonight, there's 15 questions in it, which is actually better for you because if you look at the settings and you read this, you only need to get 12 out of 15 to get an 80%. So you can miss 3 questions. How many could you miss yesterday? Only 2. So you have to answer 12 questions right if you can get 3 of them wrong. So you have another sort of available goof up if you need. Did we make it all the way? Sorry, Helena.
For the thing, I think it was just like you could only miss 3 because I got 11 out of 13, but I got like 84%. Mm-hmm.
Yeah. So, but there weren't 14 questions. There were only 13.
But I mean,
Yeah, so you got 11 out of 13, which was like an 85% free run. We made it through this yesterday, right? Where we were combining parts. Ooh, I need to quit hitting this. We were combining parts of numbers based off additive inverses. Who can remind us what the definition of an additive inverse is? That was in our notes yesterday, Tom.
A number and its opposite added together, which makes 0.
Yeah, a number and its opposite, which when we add it together makes 0. So if we look down here, I want you guys to try to remember those skills from yesterday. And I want you to break up these numbers. Now, wait a minute. These aren't opposites. So would we break them up if they have the same sign? If they have the same sign, what's our rule for when they have the same sign and we're adding? Andrew? Just add them together. What about the sign?
Keep
Yeah, you save the sign or the sign stays. So the first thing we should do with this is write down that in my answer the sign will be negative. It'll catch up. Give it a second. It's got to wake up. Hopefully Smart turns on. There we go. So first thing you want to write is that your answer is going to be negative, just so you don't forget to do that. Then, so we said the sign stays because we had the same sign, and Don told us then that all we have to do now is just add the numbers together. Am I able to add these fractions how they are right now? When would I not be able to add these fractions, Elena?
If the denominator was different.
If their denominators were different, I would have to make them match before I could start. But since they're the same, I can add them up. So I had 3 and 9. What's 3 plus 9? 12. And then I had 4 and 4, right? And I get 8. Thank you. This is one of those times that I am intentionally making a mistake to see who's paying attention. Do we add denominators?
No.
No! Think about this. If you have half of a pizza, my buddy teaches 5th grade. He loves this question. You have half of a pizza, and somebody gives you another half of a pizza. So now you have 2/4 of a pizza? He loves showing this to his kids because this doesn't make any sense. When you simplify this, it's a half. That's what you started with. This is why we do not add the denominators. Your denominators are telling you what units you're working in. We're working in the units of halves, so our answer is in the units of halves. Here, we're working in the units of fourths, so our answer has the units of fourths. Make sure you keep your negative. What's 12 divided by 4? Ellie? 3. So we get -3 for our answer. Now, rational numbers you will also often see written as decimals, and quite frankly, we do a lot more with decimals in the world than we do with fractions. The main time that you will ever see fractions, anyone ever do any construction or help your mom or dad or anybody build anything or measure anything? Yet why do I say up there the U.S. standard measurement system will force you to work with rational numbers? Why? So I have a giant pet peeve that we still use the U.S. standard system of measurement. Does anyone know where this kind of like pet peeve comes from, or what story relates to that? Anyone ever heard of do you know about the treaty? So back in the 60s, there was this thing called the Treaty of the Meter. And it was an agreement between like a bunch of countries that everybody was going to use the metric system so that we all used the same system of measurement. We signed this treaty. Guess what we didn't do? Switch to the metric system. So the rest of the world, pretty much, anywhere else you go, uses the metric system, which is easy. It's a base 10 system. It's broken up into tenths or hundredths or thousandths or things like that. How many inches are in a foot? 12. How many feet are in a yard? 3. How many feet are in a mile?
No idea. Like 1,000.
5,280.
5 tomatoes. In a mile, there's 5 tomatoes. 5 tomatoes. That's how you can remember feet in a mile. 5 tomato. 5280. 5 tomato. So, this is why the U.S. system of measurement is malarkey, because we have all kinds of different bases. So when we have the opportunity, we will work in the metric system, which uses decimals. So, our decimals here, do we have the same sign or different sign? I want to see whose brain is turned on. Take a minute, try to solve this. We have different signs there. Yes. First thing you figure out is which is more powerful, which sign gets to stay. Then we have to figure out what the value is. So you can check back to the front of the notes if you forget anything that we're doing. Feel free to check back to the front of those notes.
Please excuse this interruption. Last call for pictures. Anybody that has not had their picture taken,
twice.
please come to
Once in
the
the
lobby at
courtyard.
this time.
Once in the lot. If you didn't get the courtyard one, it's too late for that. But if you did, everyone got their Life Touch picture taken, right?
What's Life Touch?
It's a photo company. which actually, funny enough, Small World. Have you ever heard It's a Small World? Not the ride at Disney, but so the guy out there taking pictures, Chad, he was actually the neighbor of a good friend of mine. So it was funny. I walked in and I'm like, Chad, what's up, man? All right. Question or answer? Question?
How come they always call somebody or they always announce something like all the
They have so
time?
many announcements.
Because we have to do school-wide. Well, so as we get into the school year and they know kids' schedules, then they'll call specific rooms for people. Like if they're looking for the custodian, they have to call the whole school. Like Robert Williams, that's the custodian. So that means that they're just looking for him to take care of something or whatever. So back to this. Who can help me through the whole process and explain your step-by-step? Jeremiah, you beat her out by a couple seconds. Ellie, she was right after you, but
Okay, so I basically took away all of the signs and just did 8.3 minus 5.1 and then dropped the sign and just put a negative because 8.3 is larger than 5.1.
okay, so I like what you said, but I'm going to turn your process around. So first thing we should do is think about the sign. So you said I got rid of all, but before you get rid of all of them, just grab whatever sign goes to the answer. So I look positive, negative. Which one has more power? The negative. So I bring that down and I know that my answer will end up negative. Then Jeremiah said all he did was subtraction or finding the difference because they have different signs. So we always do big minus small then. And what'd you get?
I got 3.2.
3.2, so then I bring that down into my answer space. So this is what some good work would look like. There's not a lot of work, but I show that the negative has more power, so I bring the negative down. You don't necessarily have to draw the arrow or whatever, but that's what I do to help my brain. Then find the difference between them, 3.2, it becomes negative. Question?
Why did you go to the minus?
What do you mean?
Why did you switch to subtraction?
So if we remember our rule from yesterday, let me capture this, then I'll run back up the notes. If you go back to the front of the page here and check your different sign rule, because these two numbers are essentially getting in a fight, 5.1 is positive and it's pulling this direction, and 8.3 is negative and it's pulling this way, we're saying which one has more power? Well, they're going to have to cancel each other out. So think of like a tug of war. If one person has all of the power, all you do is go that direction however much they pull. But they both have power. I have some positive and I have some negative. So when we have different signs, we go back to our rule right here, determine which number has more power. That's how we took the negative. Then, because we have to find out, well, the negative has more power, but how much more does the negative have? So then we find the difference to determine how much more that negative has. And it wins by 3.2. Yeah.
How would you really subtract the negative? Because if you did -2 minus -5.
We're going to get to minus negatives. Don't hang on to that thought. That's on the next notes page. Yeah. What do you mean? So the multiplication division rules are different than the addition subtraction rules. That's why this whole chapter is addition subtraction. Next chapter we'll get to the multiply divide rules. So that's a great question from Anish. These are only addition and subtraction rules. Only. Do not think about these as multiplication division. So do not think about any multiply divide yet. Last one here. Try this on your own. I bet you only need about 50 seconds because that'll take us back. I know. You can work ahead, and some of you are probably already done with this. So while you're doing the got it, I'm going to go ahead and hand out our next notes set. Always take your sign first, then figure out what the number is going to be. Yes. Take one, pass it back, please. Take one, pass it back. And same one. Oh, that's your stuff behind you. Okay. So, Ozzy, because I love to make sure that we have solid understanding now, you just explained the process to me back there. Can you explain it to the whole class?
If different, if they're positive and negative, if they're different, you find the difference.
So I'm going to need to find the difference because their signs are different. But the first thing I really want to do is think about what sign your answer will have. What sign will your answer have? Positive, because why? Yeah, its absolute value is greater. It has more power. So then what's the difference between 3.2 and 2.7? If decimals give you a hard time, here's a trick you can apply. As long as I start with my decimals lined up, I can for a moment act like my decimals are out here. 32 minus 27 would give me 5. But then my decimal's not there. It's actually here. So I see that I actually get 0.5 or 5/10. Now wait a minute. But 3 minus 2 would be 1, wouldn't it?
But you have to know.
Dom?
It's because 2 is too small to subtract from 7, so you would take 10 away from the 3 and make it 12.
There was a borrowing that happened here. If you forget about your subtraction process, remember, I can't take 7 away from 2. I can easily think the difference between them is 5, but I can't take 7 from 2. So I have to borrow, and the difference is still 5. I just have to borrow first. So my answer becomes a positive 5/10. Yeah.
Would subtraction be like make the one which has like negative, like the one which has lower, and then add it?
Say that again. Are you asking about a subtraction process? Hang on to it, okay? Subtraction is right here. So, 4, 4, 4, 5, make sure your name is on the top of this. Hey, Jeremiah.
Also, in 6th grade, we did do subtracting negatives, but I forgot it. But when you do it, the negative signs cancel out each other.
2 negatives become a positive. You're a step ahead of us. So, always we show you the arithmetic and the algebraic. So the arithmetic always has actual physical numbers in it, and the algebraic always has, what are these called again? Variables, thank you. So this is saying 5 minus 7 is the same as 5 plus negative 7. So what we just did, this addition with negatives, we did this once yesterday, I believe. If you have an addition of a negative, it's going to add in the negative direction. So it essentially is subtracting. So we can turn a subtraction into addition of a negative, or we can turn addition of a negative into subtraction, whichever way works better for you. Now the reason they do this is I can't really take 7 away from 5. That doesn't really make sense, but I can start at 5 and go 7 in the negative direction, and if you want to write right here, what would your answer be? -2, right? Here, minus a negative. I want everyone to put a little V under them. And then over here, we're going to do minus a negative. What happens with these is they become a positive. Now, this only works when they're right up against each other. The parentheses does not count. That parentheses is just a grouping symbol. It actually is unnecessary. So that parentheses doesn't count as actually existing there. When the minus and the negative are right up against each other, you can essentially think about it as just shoving the whole thing together, and the 2 minuses form into a positive. So when they're right up against each other, they can shove together and form into a positive. So minus a negative is plus a positive. So you might, off to the side, want to write minus a negative is really plus a positive. And you could show it right here as well. A minus B would actually turn into A plus B. Jeremiah?
And I want to know, does anyone here, besides someone I went to Worthington in the States, do they use ST Math in 6th grade?
Yeah, probably all of you guys. So some of that was individual, like how far you got was individual basis. All right, so I need some help. We need to write 2 different expressions. Now, does anyone know the difference between an expression and an equation? The difference between an expression and an equation. Come on.
An equation
Yeah, and an expression normally needs to involve some kind of operation. An addition, a subtraction, multiplication, division, something going on. So we need to write two different expressions, one subtraction, one addition. So what number do you think would go in this first box? Where do we really go to first? Or now we really start, quote unquote, at 0, but we don't say 0 plus. So instead, what's the first number that's really our reference point? Solomon? -2. So -2 would be in this first box here. Then what happens to it? If I use the minus, if I'm using the minus symbol, you might highlight that one is minus and one is negative. Or sorry, one is minus and one is plus. That's what I meant to say. Julian?
Wouldn't you put the -7 here and then turn the negative on the 7 and the minus into a plus?
Now -7 is actually my answer. So if we wanted to use the -7, that's out here as my answer. What we're asking right here is what change is being done to the -2. Like this red line essentially is what that is showing me. So what change is being done to -2? It is going 5 more, and this subtraction tells it the direction to go. Now if I use addition, I still start at -2, but what would I be adding? If I use addition, I need to, Jeremiah?
Add -5.
-5. I would use parentheses to group my negative, and I still land at -7. Try the second one right here on your own. Do the blue. You might have to look up here to see colors. Do the blue first, then the red, because blue starts at 0. So do blue first, then the red. And then we'll put out here what it equals. And we can see it ends up at -1. By the way, I make my ones like this because as we get into using variables and we use letters and more things, it's just easier to make your ones like that. So you don't have to, but that's also why I'm just trying to show you guys, so as you watch me write numbers, you understand. My 7s will almost always look like this, so you make sure you know it's not a 1, it's a 7. Who thinks they know all of this? Andrew, we haven't worked much yet today.
Okay. So it starts, so in the first box it's 6.
6, so that would be the same for both of these.
And it's going back 7, so it's -7.
-7
-1.
equals -1.
And then for the second one, it's 6 plus negative in parentheses -7.
Yeah. And actually, if you wanted the technical way to say that, we would say 6 plus the quantity of -7. But since there's only a number in there, you can just say 6 plus -7. You don't have to say anything about the parentheses. Later on in math, if we have 6 plus the quantity -7 plus 4z or something like that, then we would say the quantity because there's more going on in there. But we don't need to right now because it's just -7. No, because there was nothing to multiply. So hang on, you got the right idea where if we have parentheses, we would distribute. But that would be if we have something up against the parentheses, like that, then we would distribute. Because we use the distributive property to multiply to multiple things. We distribute multiplication. All right, we all good with the number line representations. Any questions?
I forget how you did the second one.
So we start at 0 and we say, what's my first
Why did
shift?
you start at,
So we always start at 0. We always, when we start, we all started at 0, right? When I start counting, I have nothing, then I have 1, then I have 2. So we always start at 0. But if I actually wanted to write out everything, now a lot of times this year I'll say mathematicians are efficient. We stop writing out unnecessary things. I really start at 0 and go 6 to the right. So if I wanted to write out the whole thing, I would say 0 plus 6 took me to 6. Then minus 7, so I walk 7 in the minus direction or the negative direction, and I land at -1. Now, if instead of using subtraction, I want to use addition, I don't go in the positive direction, which is what adding normally does. So that's when I have to add the negative value to go in the negative direction.
But this is saying you know what the answer is going to be. What if you don't know what the answer is?
Well, then it wouldn't show us everything on the number line. So then we might have to draw it on our own. But yeah, this is when we know the answer. Any other questions before I clear it and move on? Once, twice, sold. So again, we know our answer here. Be careful, multiple choices are trap doors. Most people look at a multiple choice to try to answer it really quick. They make a mistake. So be careful. Which one do you think this is?
You start with blue. Blue.
Start with blue. And there could be multiple answers. Probably by Monday, I'll have name cards. So those of you who have kind of just been riding on the whole I don't raise my hand and I've been getting away with it, as of Monday, it'll just be random choice of who I asked to help me out. Monica, what do you think?
1 and 3.
1 and 3. So if I start by going up 2, then I get told to subtract or go down 4, that would land me at -2. So 1 does work. 2 minus 2, well, that wouldn't make any sense. 2 plus a -4, well, if I'm adding, I have to go in the negative direction, and that would give me -2. So that works, and 2's out, and 4's out. So 1 and 3 are your correct answers. Now, we have questions just like this, got it, on your homework tonight. We like to talk about records in America, well, actually, really in the world, because we like to know, who holds the highest or the best or the longest, or who survived, because really all of human existence is about survival. So, the fact that Evel Knievel jumped to this giant gap and he survived, that's people are always happy when we survive. So, the highest recorded temperature in the United States, in the U.S., 134 degrees Fahrenheit. Now, if that was Celsius, you'd be vaporized. 134 degrees Fahrenheit is the highest recorded temperature ever in the U.S. Now, the lowest temperature ever recorded was 214 degrees lower than that temperature. So I want you guys to take a moment, try to calculate what the lowest temperature actually was, because if it was lower, you can either subtract or add the negative.
-86.
Which of these do you prefer? Would you rather subtract, or would you rather add the negative? And this is really kind of an opinion question, but I'm curious. Acadia?
I would rather subtract.
You'd rather subtract, so you would set up the 134, and then you'd do the borrowing sort of thing to deal with any subtraction, borrowing that has to happen?
Yeah.
So, here's the problem. 4 away from 4, I get 0. 1 away from 3, I get 2. 2 away from 1. Doesn't really make sense, right? So that's the only scary part about doing that, is this can fall apart, especially if these numbers didn't work out as well and we started trying to borrow. So I would prefer, obviously if you have a calculator, you can punch it in and it does it for you. But on your homework tonight, I want you to try, I obviously have no control, you go home, I don't see you. I want you to try your first time through, no calculator. Because there will be times, there will be questions, there will be assessments that we don't use calculators. So I want you guys to get your brains turned on to how do I do these things without a calculator. And if you're trying to do this without a calculator, it is easier to take a smaller number away from a bigger number than to take a bigger number away from a smaller. So this, my red writing up here, is actually the better problem to set up, because then which one is more powerful, the positive or the negative? The negative, right? So I know that that would be negative. And then I can take big minus small. Sorry, I should write this in red since it goes with my red problem. 214 minus 134. Now 4 minus 4 is 0. I can borrow from my 2. 11 minus 3 is 8. And then 1 minus 1 is 0. So then I get negative 80.
Oh my gosh, I did that now. That's what I did.
And that, I believe, was in the Arctic Circle, I want to say is where that was. Jeremiah?
You know it's weird. You can use like positive and negative for almost everything.
Yeah, like direction, north is positive, south is negative. A lot of times people say east is positive and west is negative, which here, if you ever want to orient yourself in Phoenix, north, south, east, west. So we're on the west end of the building. The academy is the west end. Rockbridge is the east end. So if you ever want to orient yourself inside, I know there's no windows. Sometimes it's hard. So what is our trick? What do we remember about minus a negative? We just did this higher up on your paper, and I asked you to write it, but we're going to write it again. Minus a negative initially.
Minus negative because it becomes a positive.
Ooh, but what a positive. Yeah, minus a negative is really plus a positive. So you guys should all write this right here. Minus a negative is really plus a positive. So if you're being asked to take away a negative amount, now wait. So, and it wasn't in this class, but yesterday in another class, I acted as if I borrowed money from somebody. So let's say you borrowed money from your parents. You borrowed $5. You want to buy, I don't know, pizza. Yeah, you went to Little Caesars. So how can you get rid of your debt of $5? So we're trying to subtract this negative value, because right now you have a debt. Dom? Yeah, you pay them, you give them a positive $5. So to get rid of debt or subtract negatives, we add positives. So for Dom to pay his parents back, he's got to give them a real positive $5. So here, I want you guys to rewrite any of these that need rewritten. So this first one, I see minus a negative. I rewrite that as plus a positive. So really, it's negative 3 plus, or negative 4 plus 3. I always do the V. And if you don't, this is where mistakes come in. Trust me, I've seen it on your mastery assessments. You guys show your work. Whether we take the mastery on paper, whether we take it on Schoology, you still turn in a corresponding page of work. And when I see people writing this out and they haven't combined their negatives and like they make the mistake, take the millisecond or whatever it takes to show what you're doing so your brain knows what's up. Because addition's easier. Now, which one's got more power, the negative or the positive? And the negative. And Sean, what's the difference between 4 and 3? 1. Boom. Done. So take a minute. Try to finish out the rest of these. The rest of this whole first page. The other 5 of those.
So the one on the right, you turn to a positive?
Yeah, so we grab the 2 negative symbols. We use both of these to make the positive. So there are no negative symbols left except for what's in front of the 4. So here, I'll show the work for this one. If we grab these 2 negatives to make a positive, because they're right next to each other, remember that parentheses doesn't count, it's now that. Or if we grab these 2 negatives, it's now that. No, you turn the number where you took the negative. You cannot just think you turn one of them into a positive. It's whichever one you used that negative. That's why we're drawing this little V, because we're using both negatives to make the positive. We didn't use this negative. I didn't touch it. It was way out here on its own. It stayed negative. These negatives, I used that subtraction and that negative to make this addition. So these are both gone. They got used. This one did not get used. It falls down, carries down, follows through. Whatever you guys are used to saying, it comes down the problem and stays. Dom, question or answer?
On the one where you have 6 plus 1, is that 6 a negative? Because to me it just looks like 6 minus -1.
Yeah, this is just 6 minus -1. The 6 to start is not a -6. It's a positive number to start. So all I did here was match up pairs of negatives because, guys, remember, this is negative, subtraction, opposite. It has a lot of names. So whether you call it a negative or a subtraction doesn't really make a difference. But I have a subtraction of a negative makes a plus. Subtraction of a negative makes a plus. All of these, we have subtraction of a negative. Join them up makes a plus. So what is my answer here for the second one on the top bar there? Katie?
7.
Turns into just 7. We took away a negative value, but really that was adding. Ellie, what about my next blue one here? 3, because the positive has more power. The difference is 3. Evie, is that a hand or you just like the black one or the red one? All right, do it. 7. Because 1 minus -6 minus a negative is just plus a positive. Our blue one here,
Not blue.
Elena, or red. Wow. What do you got?
1.
Yeah, -3 plus 4 is 1. And Noah, what about our last one here?
-3.
-3. Thank you very much, sir. Any questions on any of this? Flip on over to the back. No, we have like 4. 3 to 4. This class is over at 48. So, the biggest thing when it comes to fractions, and your homework tonight is all integers or decimals. So your homework tonight is pretty easy. That's why I said don't use a calculator. Try to do it with just your brain. Your homework, probably the next homework assignment, which you might be able to do tonight. If I make it live, I'll let you guys know at AO. Or I'll let you know at lunch. Like I'll just make an announcement. But the biggest thing to pay attention to is the denominators. You got to have those matching denominators. So that's that trap door. When we're adding or subtracting fractions, always deal with the denominators, then deal with all your sign work. So here's another reminder. If you start with subtraction, you can turn it into addition of a negative. Or if you start with subtraction of a negative, you can turn it into just addition of a positive. And really, some people like to write minus a minus equals plus a plus, which you can, but we don't have to write that B is positive because we just know that it is positive. Like, we don't have to put a positive sign on it. So if we look at this, got it right here. I have -1/5 minus a -1/5. So what would be the first thing that you think about doing there? Like the absolute first piece of work? Finish? Yeah, always look for a pair of negatives. So pair up these negatives. Take it easy, Chad. Have a great day. So then I carry down my -1/5 because nothing happened to my first value. These paired up to make the plus, and the only thing I have left is the 1/5. Notice you can write your fraction either way. You can use a diagonal slash. You can use a horizontal. I don't care. I would appreciate if you chose one of them and stayed consistent because I did this on purpose to show that this doesn't really look that nice. It's okay, but it doesn't look very nice. So try to choose whether you do slash or whether you do the straight across and just go with that. Jeremiah?
Made up all the legs by using yours. I would turn the V, so I would do the little triangle, upside down triangle.
Yeah.
And I put the plus right there in the middle, and then I make the circle right there at that negative sign to make it go away.
Oh, these you circle?
No, that will be a plus.
Well, you're circling this one?
The middle one will be a plus, and then that one will be just a circle. Like I scribbled it out.
Show me here after class. I'm curious what you're doing, but we just got to finish this up. So if I have a -1/5 plus a +1/5, what would I have?
Put the
Evie? 0. They're opposites. They're additive inverses. We will finish out the rest of these notes tomorrow and probably do one more page of notes, and then Friday, I'm guessing, will be a work day. Huh? Yeah, both. That's real. All those quantities are actually what they should be. So instead, like, I don't like having a bunch of extra like stuff written that I don't need. So that's why when I grab these, I'm kind of showing I use that minus and that negative to make this plus because there's 2 lines. So that works. If that works for you, good. But the reason I do it with this is to keep it a little bit cleaner. Does that make sense? So if that works for your brain, have at it. You're good. I know. Thanks, man.